do you think? You think so? Okay, so why, let's back one step at a time, and first let me unfreeze my line. Why can we get rid of the 1?
Because
It says n cannot equal 1 in the problem. It says specifically. So selecting B is automatically going to be a mistake. So I was trying to figure out some answer choices. If you were going to guess, what kind of answer would you guess based off that weirdo fraction?
-2.
I would guess something negative. I would. I kind of wanted to guess -2, but notice it says n is a real number. So I'm going to, maybe it's 0. I wasn't really sure where this problem was headed. So when it says n is a real number, I pick real numbers. So let's see, I'll do 7. I love 7. 1 plus 7 over -7 plus 1. I get 8 over -6. That's -4 over 3. I need to know the decimal.
That is -1.3 pretty much.
Okay, we'll put 1.33. We'll leave it there. Thank you, Mom. Okay, so we tried 7. That was a pretty small number. Let's try a really large number.
12.
I want large. 80. That sounds large.
No. 1 million. 1 million.
260 it is. That's the one I was thinking of, so I'm going with myself. 260 it is. I'm just making, yeah, you could do whatever it is you were really desiring to do. I'm going to do 260. Okay, so I get 261 over -259. Again, I need to know what that is as a decimal.
Why do you keep doing this curly?
When I round, I put the approximation symbol rather than the equal to symbol. It's just me being a super nerd. It's fine if you don't do it. It's just when I round.
So it doesn't mean anything?
It just means I rounded. It's my way of telling myself I rounded on my decimals.
I'm super nerd.
What did you get when you typed it in your calculator?
That one?
Yes.
Let me do it now.
I need someone who has done it and not be being goofy and actually be having the notes on and be motivated. That's what I need, but this is what I got.
I'll get mine up. -1.00772.
Okay. We'll stop there. So we did a small number. We did a pretty large number. What other kind of number should we test out?
A middle number in the middle.
She wants to test out a middle number, so 50 sounds good. And let's do 1 plus 50 over -50 plus 1. I get 51 over -49. I need to know what that is as a decimal.
-1.040.
Okay, so we tried a small, medium, and a large number. What other kind of numbers should we test out?
Negative.
A negative number would be a good number, and then Juliana wants to do 0. I'm going to leave poor 0 out of this, but he would be always a good one to test. So let's test 0 really fast. You get 1 over 1, which is 1. Negative 1. You know, it's just 1. So that 0 is no fun. That was no fun. Let's do a negative number. I love 7, so we'll do -7.
Why do you like 7?
I don't know. Oh, that should be a -7. Oh, let's start all over. Should be 1 minus 7, because it's a -7, over -7 plus 1. So I have 1 minus 7, that's -6. -7, well, that's a +7. +7 plus 1 is 8. So -6 over 8, I need to know what that is as a decimal.
-0.75.
Okay, looking at these answers, we've gotten -1.33, -1.07, -1.04. 1's like a weirdo outlier. He does not follow my pattern. And -0.75. Besides this one, because he's not doing what I want him to do, everyone else kind of is pointing to a certain answer choice. What answer choice is that? -1, which is D, which is why I went with D.
Okay, so what?
So-
So if you get these on the test, you're supposed to make up random numbers until they all equal.
So you find a pattern.
Until you find a pattern, because n is a real number, meaning pick some real numbers. See what happens. If you plug in any real number you want, and I wouldn't go in order 3, 4, 5, 6. You want some spaced out ones, the way we did 7, 260, 50, some that aren't right in a row, to see if there is a pattern of some sort. There might be, there might not. There was in this case. Coming back to -1. It's got to do with limits and stuff in calculus, which eventually I hope many of you will get to. But for now, mostly the whole point was, It says n is a real number. Pick some real numbers. We keep seeing the same sort of answer coming out, so that's why we're going with D.
So is there any possible way that somebody else could have chose, the people who came with the call chose like other numbers and they all got -2?
If their fraction was different. It's all because of this fraction here that the answer happened that way. Okay, so we have our notes from yesterday. We were talking about triangles and how they were proportional. I'm pretty sure you had that down, or at least it seemed like it. The parts with parallel lines is going to be just as easy. So if I were you, I might have out a highlighter or at least a color of some sort. You're driving me crazy. Taylor, I don't know what you're doing, but now you've made my YouTube video. Okay. I know that you know all about parallel lines and all the angle relationships. I know you can do alternate interior, alternate exterior, all that jazz. This is not anything to do with that. It says something about 3 parallel lines being cut by 2 transversals, but what we're going to focus on is still the proportions. So, AB over BC should be proportional to, or we could set it equal to, EF over FG. So I colored it yellow and gray. The yellow over the gray equals the yellow over the gray. The yellow over the gray equals the yellow over the gray. Notice one line gives me one fraction. The other line gives me the other fraction. So when I set up my first problem, it says example 3. So I'm going to make that yellow and this gray. My first fraction is going to be yellow over gray, so 13 over 26. In my second fraction, do I put 16 over x or x over 16?
16 over x.
16 over x. Because I'm doing yellow over gray, so I've got to be consistent. I'm doing yellow over gray. If you want to reduce the fraction and all that jazz, you can. I'm just going to go ahead and straight cross multiply. So on the diagonals, I have 13x equals 26 times 16. I need to know what that number is.
460.
Okay.
So if I would have did 13 over 26 and x over 16, I would have got the wrong answer.
Yes, because your proportions, I did yellow over gray. You've got to do yellow over gray. Meaning I did, if you do 26 over 13, then you could do x over 16. They've got to be, the proportions have to stay the same. 26 and x both have to either both be in the denominator or both in the numerator. Okay, so you divided, and what did you end up getting?
X equals 32.
Great. Okay, I need the front 3 groups, I'm coming to count, the front 3 groups to try number 1. The first thing I need to fix, it shouldn't say a 3x, it should just say 3. I need the front 3 groups to try number 1. I need the back 2 groups to try number 4. When you've got your answer, go ahead and tell me. And it's going to be okay if it's weird decimals. I'm good with weird decimals. X equals 0.63 is what she got for number 1. Yes, dear. Yeah, I did 3.33 as well.
X on 4 or y?
Oh, it should be Y. You're right. Thank you. Okay, so if we're going to write each of these down, Juliana, I bet, did those as yellow and these as gray. So she did 3 over 5x. One line gave her one fraction. she did 12 over x plus 12. Are there any questions about how I'm setting this up? When I cross multiply, I get 3 times x plus 12 equals 5x times 12. So I have 3x plus 36 equals 60x. When I subtract 3x from both sides, I get 57x. So I end up with this weirdo fraction, 36 over 57. And when Juliana typed it in her calculator, she got 0.63.
Well,
I am confident that you can do the cross multiplying.
36 minus 60 minus 36 is
60 minus 3 is 57, Jesus. Let me press the little button on my camera.
okay, because it's X.
Now, you're welcome. Okay, so I cross multiplied. I made sure I distributed. Did you distribute? When I subtracted 3x from both sides, I had 36 equals 57x. I ended up with this weirdo fraction. I'm okay with a decimal. Are there any questions about number 1? Okay, can someone, not Savannah, tell me how you set up number 4?
Okay, 5 over 8 equals y
Over
over
y
y plus 2.
Oh, perfect. I'm so glad that we all are on the same page. So when you cross multiply, you got 5 times y plus 2 equals 8y. So 5y plus 10 equals 8y. So 10 equals 3y. So 10 over 3 equals y, which is how you got this weirdo decimal of 3.33 or 3.3 repeating. Are there any questions about number 4? We're almost done. We're on with number 3. What makes number 3 look different than number 1?
Y.
Well, yeah, but what makes number 3, looking at the pictures themselves, what makes it different from number 1 and number 4? That's what I'm looking at. Notice the congruent dashes. So I'm not going to have to set up a proportion at all. I love problems where I see the congruent dashes. I don't have to set up a proportion. I don't have to cross multiply. I get to do what I wanted to do. The x pieces are equal. So 2x plus 4 equals 3x minus 1. Someone solve for x. Tell me what you get. And you'll beat me to it. What is it here? Okay. Good. That's what I got too. Okay. So we knew for sure the x pieces were equal. We solved. We got a value for x. If I wasn't trying to do this quickly, I would plug it back in, make sure they both match, because I want my A in geometry. Because the x is equal, I know I can see over here that the y pieces don't have those dashes. I see that, but what we would have done is we would have set up a proportion. This over this equals this over this. That's what we would have done. So if these two are equal, these two are automatically equal. So I also get to do 3y equals 2y plus 2. 3y equals 2y plus 2. I get to set these two equal because the x pieces were equal. So it's like we get something for free. So when I subtract 2y, I end up getting y equals 2. Oh, that's what you were telling me. Duh. I being special for a second. I got it now. Okay, so you have to evaluate when you get a drawing or a picture or whatever you want to call it. If it looks like 1 or 4, yeah, you set up your proportion cross multiply. If it looks like 3, you don't even have to set up proportion cross multiply. All your dreams come true. Since the x's are equal, the y's are also equal. Okay, and then we have this weirdo caret on number 2, and I know you had a weirdo caret on your worksheet. How do you think we handle this? Do we have to set up a proportion?
Well, I didn't know that.
I know, but looking at this now, looking at this caret, do we have to set a proportion at all? No. Why? Oh my goodness, all these dashes mean all the pieces on the left were equivalent. They all equaled. So all the pieces on the right should be equal. So you can do 12 equals any of them. I'm going to do 12 equals 2x minus 6. You could do 12 equals x plus 3. It should not make a difference. I get 18 equals 2x. So 9 equals x. And you're going to say, Ms. Compton, I don't think you're right, because you only used that 2x minus 6. You didn't use that x plus 3. But if I plug it in, 2 times 9 minus 6, that's 12. I know the middle piece of the carrot's right. 9 plus 3, that's also 12. I know the bottom piece of the carrot is right. So I know I'm right. I've done this all correctly. So you're really praying on most of them to see those congruent markings, because then suddenly your life is so much easier. There's no proportions. There's no cross multiplying. It's just a simple solve. Are there any questions about any of this? Then you already have your 7-4 worksheet. Go ahead and get it done. If you can get it done, get it checked, and that is awesome. I'll let you finish your task, work on whatever. I'll let you do whatever it is.